find out. Okay, so my name is Josh Willis. I'm a climate scientist and an oceanographer here at JPL. And I'm also the project scientist for the JASON 3 mission, which is a follow-on mission to the JASONs 1 and 2 and TOPEX Poseidon, which came before that. And what that mission does is measure the height of the ocean from space. And it's really an incredible technological development, even though it's been around for 20 years. This technology has been doing this particular job for about 20 years. Essentially, they can measure the height of the ocean with an accuracy of about 1 inch from 800 miles in space. So there's a big footprint, and it averages over all the waves and stuff like that. And you can see how tall the ocean is from space. And this is really important to me as an oceanographer because oceans play a huge role in our global climate system, as you can imagine. So how much of the planet is covered by oceans? You guys know? 70 something? Yes, over 2/3. That's right. Over 2/3 of our planet is covered by oceans. And so, as you can imagine, Arthur C. Clarke once famously said we shouldn't call our planet Earth, we should call it planet Ocean, because it's more ocean than it is Earth. So you can imagine that as our climate changes, as we drive our climate into a new realm by adding CO2 to the atmosphere, really almost all the changes are happening in the oceans. So if you think about climate change, if you ask, where is climate change happening, the answer really is in the oceans. We think of it as happening to us because we live in the atmosphere. We think of it happening in the atmosphere, and a lot of times when we talk about global warming, we talk about the rise in the temperatures of the whole planet, the surface of the planet. But in fact, really, it's the rise in temperatures of the oceans. Over 90% of the heat that's trapped by greenhouse gases is warming the oceans. Over 90%. So in other words, the oceans are really our barometer for how much we're changing the climate. And the reason that missions like JASON and JASON 2 and JASON 3 are so important is because they measure that rise in the oceans. If you have an accuracy of about 1 inch over a single spot on the Earth, and then you fly around the planet for about 10 days, you cover almost the entire oceans, then you take this measurement over and over and again, then in 10 days we can essentially measure globally averaged sea level. Essentially, we can measure the volume of the ocean and how it's changing. So 2/3 of our planet covered by oceans, we can see those oceans slowly rising. And they rise for two reasons. They rise because glaciers and ice sheets are melting, of course, in places like Greenland and Antarctica, and also lots of tiny little mountain glaciers all over the planet. As the atmosphere heats up, as the ocean heats up, these melt, and that meltwater eventually finds its way back into the oceans. So we can see this rising of the oceans from space, from our space satellites. And I like to say that, in fact, this satellite and its predecessors, JASON, this one's JASON 2, I believe. It might be JASON 3. Anyway, they look almost identical. These satellites are really our yardsticks for measuring global climate change because the sea level rise represents the increase in water. It represents the melting of glaciers and ice sheets, but it also represents thermal expansion. It turns out when water gets warm, it actually heats up, it actually expands. So expanding water is one of the causes of global sea level rise. And we can essentially measure the sum of these two things. We can measure the thermal expansion plus the runoff from space using satellites just like this one. And that's really why they're so important. They're really our most accurate tool for measuring global warming. Recently there's been a lot of discussion about a pause in global warming, that the surface temperatures were going up really fast and they seem to kind of level off. And I like to say that paws are for kittens and puppies and not global warming. Because in fact, global warming hasn't really paused. If you look at any other measure, if you look at sea level rise, if you look at the melting of glaciers and ice sheets, if you look at sea ice loss in the Arctic, all of these things are just continuing on. They're all still happening. There is no pause in global warming. The surface temperature bounces around because of natural fluctuations a little bit, and if you pick the right period, then you can make it look like there's no warming over a period of time. But in fact, better measures of global warming, like the ones that come from these satellites, show that sea level rise is continuing, and in fact there is no pause in global warming. If anything, global warming is accelerating. So I know there's a bucket up here, and you're probably all wondering why this bucket is here. And the bucket's part of this demonstration that I've been doing for a whole bunch of years now. I like to explain to people why it is that the ocean is really so important for measuring global warming. And like I said before, over 90% of the heat trapped by greenhouse gases is going into the oceans. Now, why is that? Why is all the heat going into the oceans? Yell it out. This is the question and answer part. Because of the heat capacity. Yes. Oh, you've seen this demonstration. Never mind. So yeah, exactly. The heat capacity of the oceans is enormous. And water, it turns out water is just really, really good at sucking up heat. And that's why over 90% of that heat is winding up in the oceans. And there's a nice little demonstration you can do. If you take a balloon, you can think of the atmosphere. I like to say that the atmosphere is kind of like a piece of tinfoil wrapped around a hot potato. If you put tinfoil in the oven, you can actually reach into a 400-degree oven and pick up the tinfoil. Mm-hmm. Why is that? Because the tinfoil has no heat capacity. Essentially, its heat capacity is very small, and as soon as you touch it, it's the same temperature as your fingers. But if you wrap that foil around a hot potato, and you pick up the potato, it'll burn you. And the reason is because it's just reflecting the temperature of whatever it's touching. And that's what the atmosphere is like. Really, the atmosphere is just doing what the top 100 meters or so of the ocean is telling it to do. So in a lot of ways, again, as we look to trying to understand how climate change happens, really, all the action is happening in the oceans. So if we take a balloon and we fill it with air, like this, everyone's excited, I can tell. Now, if I hold a flame to this balloon, what do you think is going to happen to the people in the front row? They're going to get splattered, somebody said? I hope not. Our insurance won't cover that. So if I hold a flame to a balloon, it pops, right? Mm-hmm. You guys ready? Yeah. I don't think you're ready. Are you ready? Here we go. 1, 2. Yes, I knew I could mess up this set. So the reason the balloon filled with air pops is because it has a very low heat capacity. But if you fill a balloon with water, then it turns out you can stand there with a flame against it like all day, and it won't pop. And I've done this experiment many, many times, and I can assure you that the balloon has almost no chance of popping. It's definitely, how was that for the mic levels? It's definitely almost assuredly not going to pop and ruin this lovely set. But just in case it does, we'll put this little balloon here, or this little bucket here. Now you're all really scared of being on the front row. Okay, so here we go. We're going to hold the flame against the balloon and see what happens. You guys ready? Because I'm not. Anybody want to get lunch? Click, click. No one's typing anymore. It's so weird. So I could really stand here literally like all day. I had a friend who's in the audience somewhere. She put a balloon over a Bunsen burner, and it remained intact. Now, if you use a blowtorch, the balloon will pop. Just so you know. But I could stand here for a really, really long time and talk to you for the entire rest of this segment, and the balloon wouldn't pop. In fact, the balloon's not even hot if anybody wants to touch it.
Water or ice water? Wow.
It's not even hot. So go home and try it someplace safe with your own garbage bag. And let's see if I can... Science!